This is Mr. Maxwell, Pingree AP Biology, and this is the tutorial for those of you who need a refresher on simple Mendelian problems and simple inheritance problems. So question number 6 is a sex-linked question, and it says the gene for red-green color vision is located on the X chromosome. This is the X chromosome, and so the gene for red-green color vision is going to be located somewhere on here. We're going to use big R to suggest normal vision and little r to be red-green colorblind. And obviously you would have to be, if you have one big R, that's a dominant allele. So a man with normal vision marries a woman with normal vision whose father is colorblind. What are the odds of having a colorblind boy? Colorblind girl. Okay, now one of the things that you'll notice is that when the Y chromosome here and the X chromosome pair up, they have large regions where the X chromosome is not homologous to the Y chromosome. So notice here there's only a tiny little bit that's actually homologous between the X and the Y. And these regions down here are called pseudo-homologous because they're not really, but this is the only real homologous region. So it turns out that the red-green colorblindness gene is not in this homologous region. So you're only going to find it on the X chromosome. Okay, so now the first thing you need to do is notice that a male and a female can only produce a 50-50 ratio of males to females. And so I already set the Punnett square up here. The question is where do the indications for the genes go? And so the different alleles, of course, are big R and little r. So if you're X big R, you're a female, XX, you have normal vision. If you have X big R, X little r, heterozygous, this is a female who has normal vision but is a carrier. This female here is colorblind because she doesn't have a copy of the dominant allele. And then this male has normal vision, and this male would be colorblind. So let's see. So the man has normal vision, so he must be X big RY. If he was X little RY, he would be colorblind. So it's got to be this. And the female, she has normal vision, but her father was colorblind. So her father had to be X big RY. And because she's XX, and she got one of her X's from her mother, the only thing that she could have gotten from her father was this X here, XR, X little r. So we know she has to be a carrier because of this. Because if she got the Y chromosome from her dad, she would not be a she would be a he. The way this is going to work out is, here's the male, normal vision. Female, she had a colorblind father, so she got this from her dad, and she got this from her mom. She can see color, and what are the odds then of having a colorblind boy? Well, the odds of having a colorblind boy are 1 in 4. Now, if you said if they have a boy, what are the odds that he's going to be colorblind? Then it's only 1 in 2 because you've specified that it's going to be a boy. Odds of having a colorblind girl are 0. These guys can't have a colorblind girl. In order for them to have a colorblind girl, she would have had to have 2 little r's here, and the father would have had to be colorblind. Okay, so one most common mistake people make when doing sex-linked problems is they forget that the Y chromosome does not have anything. This is not homologous to the X chromosome in most locations, so you don't indicate a gene here, or an allele.